Now let's move on to what does an ammeter do? And color coding this circuit, we can see that we have this, and it's red on both sides of the ammeter because an ammeter has essentially zero resistance. It's basically like a wire, and you'll be looking at that in the homework this week. So an ammeter is supposed to measure flow rate. And we would expect in this circuit, because it's a series circuit, to have the same flow rate at each of these locations. So we want to hook it up and find out if that's what we have. But we need to figure out how first to set up a meter to be an ammeter. So there's several dial settings here. 10 amps, which is here, 10 amps, and then 200 milliamps, 20 milliamps, and so on. And you can go ahead and convert those to amps. Once again, you want to set it at something higher than what you think you're going to be measuring. We have no idea what the flow is going to be in our circuit, so we would set it at the highest value, 10 amps. The black lead connects here. The red lead is going to connect to the 10A, that stands for 10 amps, DC, 10 amps direct current. If you had this on any of the other 4 settings here, the ones that are smaller than 10 amps, you would plug it in here to the milliamps plug. Okay, but we're going to do 10 amps, so it needs to be here. You always want to make sure, double check your settings before you make measurements in your circuit. So here's my circuit with 2 long bulbs connected to 2 D cells. When measuring flow rate, I would always recommend hooking up your circuit first and then thinking about where you want to know the flow and then opening your circuit to put the meter in. So this is different. When you do a voltmeter, you always measure from the outside on top of your circuit. When you're measuring flow rate, the flow has to go through the meter, so you have to actually open up your circuit. So it looks like I want to know the flow rate between the battery and the first bulb. So I'm going to open my circuit. So this is my first bulb. I'm going to open my circuit at that point and insert my meter in that gap. So here's where I'm opening it. So my meter is going to connect from here to here. So I can connect this here, and then maybe I'll use another wire to connect the other lead from here to here. Okay, so you can't really tell because all these wires are on top of each other, but the meter is part of the loop. If you follow the wires, it goes from the battery to the ammeter, right, the red wire. Then it's going to go through the black wire to the first bulb, then from the first bulb to the second bulb, and then back to the battery. Okay, so it is, an ammeter always has to be connected in the loop. We're ready to make a measurement now. I've tidied up the wires, so hopefully you can see the circuit a little bit better. So the meter is reading 0.05 amps. That tells us that the flow rate at this location in the circuit is 0.05 amps. And you can go ahead and make the measurements at the other 2 locations and confirm that you get the same flow rate at these different locations. We're going to skip ahead now to the parallel circuit and go ahead and pause the video and color code your circuit. From the color coding, we can see that we have the same pressure difference across each element, but let's take a look at what the flow rate is at these different points in the circuit. This is before the branch. The branching point is right here. This flow here is after the branches recombine. So we want to know the flow rate before and after the branching, and then what's the flow rate in each branch. So I'm going to go ahead and build the circuit. Here is our parallel circuit, and if we want to know the flow rate, the total flow rate in the circuit, we would need to insert the ammeter before this branching point. The branching is happening right here, where the total flow is happening in this wire. At this point, some of the flow of charge takes this route, and the rest of it takes this route. So this is the branching point right here. So to measure the flow rate before the branching, the total flow rate, we would need to open the circuit here and insert the ammeter here. With the ammeter inserted into that spot there where we opened the circuit, we get a reading, a flow rate reading of 0.15 amps. So 0.15 amps is the total flow rate in the circuit. Now let's measure the flow rate in one of the branches. So the first step is put the circuit back together the way it was. So here we are again at our original parallel circuit, and we want to know the flow rate in this branch. Now this is a little bit tricky because you have to be careful to put the ammeter after the branching point. The ammeter is going to go here after this branching point. So locate the branching point in your circuit and then think about where you want to put the meter. So what I need to do, I need to make an opening here. The meter needs to go in this branch. Okay, so make that opening, then insert your meter. Might need some extra wires in order to do this. And the other lead will connect to here. Okay, so it's all a little tight here, but the flow is coming this way. Here's the branching point. Part of it's going to go this way through this bulb. Part of it is going to go through this black wire, through the ammeter, and then through this bulb. Except we need to put our circuit back together. Okay, so the flow rate in this branch is 0.07 amps. And likewise, if you move your meter to measure the flow rate in this branch, you will also get 0.07 amps. From this, we can conclude that in a series circuit, the flow rate is the same everywhere in the circuit. And the symbol for flow rate is I, which stands for current. Current is the word used for flow rate. So the total flow rate in a series circuit is the same everywhere. So the flow rate here is going to equal the flow rate through the first component, which is going to equal the flow rate through the second component and through all the components, even if you had more than two. In a parallel circuit, the pattern that we see is that the total flow here from the battery in this part before any branching is going to be equal to the sum of the flow rate in the branches, however many branches you have. Flow rate is called current. The symbol for current is I, and the unit for current is amps, which is capital A abbreviated.